In this video I'm looking at trace tables and two sections of the component 2 GCSE Computer Science spec. So one is in 316, so error handling and being able to use trace tables to check code for errors. And the other one is in application testing, again similar, being able to hand test simple code designs or algorithms using trace tables. So what is a trace table? So the idea is that you will always be given part of a program or an algorithm represented in a table, and the idea is that a trace table is used to track values. So often through a loop or a function you'll have several different variables, and inside a trace table you will need to show the values of each variable at different points. So moving on to some examples. I'm going to have a look at this one, which was from the 2014 paper. So this is an algorithm. You have to have an understanding of some programming concepts to be able to do this. So we can see that this is an array because of the square brackets. What is given to us is a 4 by 8 or 9 column table, and there's 4 variables that we have to track the values of. So carriages, total, max, index. The first row has been filled out for us. What this shows us is the initial values of the variables, so we've got 0, 0 and 1. So the idea is now each time the loop iterates, we need to show the new values of the variables. Okay, so we get to this point, while index is less than or equal to 5, and because this is true, so 1 is less than 5, then this means the loop will run. So what happens to total? So total gets incremented by whatever the value in passengers represented by the number stored in index. So index is 1, so we're looking at item 1 inside passengers, and it helpfully reminds us here that array indexing starts at 1. So passengers at 1 is 100, so all we do is add 100 onto total. So total is 0, so we're adding 100, so then that makes it 100. The next bit, if total is greater than max, then, so let's work out whether that is true. So total is currently 100, max is currently 0. So this is true, so therefore we're going to run this if statement. Max becomes total. So max is a copy of total, so nothing changes about total at this point. The value just gets copied over into what's inside max. So that's the end of the if statement. And now we're here, so index is just incremented on by 1. Okay, so now I'm in the next iteration of the loop, so nothing changed about carriages there. So we have this statement, but you'll notice that this is outside of the while loop. So until index is 5, nothing is going to change about carriages. Lots of people made that mistake with this problem. So what this does is it goes back round to the top of the loop. Index is 2, which is still less than 5. So now we're going to look at item 2 of passengers. So item 2 is minus 20. We're going to add that onto what's in total. So 100 is inside total, so add minus 20, and what this makes is 80. Okay? So if you add a minus number onto a number, it's just the same as subtracting it. So now we're going to look at this. If total is greater than max, then max becomes total. So at this point, total is now 80, max is 100, so this evaluates to false, so therefore we're not going to do this. So the value of max at this point stays the same. The end of the if, and then again we're adding 1 on to index. I can spot a pattern here. I can see that every time the loop goes round, index is going to be incremented by 1. So what I can do now is I can fill those values up, and I know it's at least going to be able to get to 5 before something else will happen. Okay, so now we're back to the top again. Again, nothing happened to carriages because we're still inside the loop, and now I'm looking at the third value inside passengers. So this is 70, so I'm adding 70 onto 80, which makes the new value of total 150, and now total once again is greater than max. So because 150 is greater than 100, we're now going to make max have the same value as total. So it's going to look like that, and index is going to be incremented. We're going to go back round to the top. So now we're looking at the fourth value inside index, because index is inside passengers, because index is currently 4. So I'm looking at minus 50. I'm adding this onto 150, which gets me 100. And I know now that that is not going to be greater than that, so max isn't going to change. So now index still gets incremented, so it's going to be 5. And now the question is, does the loop still run? Well, yes it does, because this is saying while index is less than or equal to 5. So the loop will run one last time, so now we get the fifth value of passengers, which is minus 100, which obviously makes total equal to 0. And now total is still not greater than max, so max doesn't have a value change, so the if statement evaluates to false. Index does get incremented one last time to 6. What the program will then do is it will jump back up to the top, and now because this statement evaluates to false, 6 is not less than or equal to 5, then the while loop ends. So the last thing this program does is it changes the value of carriages. So carriages is max divided by 50. So max is 150, so what we're going to do is change carriages to 150 divided by 50, which is 3. Okay, so that's the first example I'm going to show you. I'm going to now move on to this one. This one was slightly different because there was just one value that they wanted you to track with the trace table. So this was a function, and what this function does is it takes in 3 parameters, so model, condition, and age, and then it returns the value of cost based on some decisions about those things. So what it's asking you to do is complete the trace table when the values passed into the function, so the arguments are tidy, so model becomes tidy, condition becomes 4, and age becomes 2. Okay, so the first one, cost is 0, so what we're going to do is put in the initial value of cost, which is 0, and now we're checking, is the model daily? Well, no, the model is tidy, so this is going to evaluate to false, so let's go to the else. If model is minty, well no, again, model is tidy, so that's also going to be false. So now we're going to jump to this else statement. Because neither of those were true, the else statement executes. So cost at this point becomes 2,000. Okay, moving on to the next structure inside the function. So this might be something that you're not that familiar with, so this is something called a case statement. It's in Python, this doesn't really exist, so it would be represented as if condition is 1, elif condition is 2, elif condition is 3, elif condition is 4, etc. But it's the same thing, so it checks, makes a series of logical tests based on the value stored inside condition. So condition, as we saw from the start, is 4, so this means the fourth statement is going to execute. So cost is cost, take away 1,000. This means 1,000 is taken away from 2,000, which becomes 1,000. So that's the end of the case statement, and now we're looking at this one. So cost is cost divided by age. This isn't nested inside any if or any case statement, so this always happens, and we know that age has a value of 2 because it was the third argument passed in, so the third parameter of the function. So therefore the final value of cost is going to be 1,000 divided by 2, so that's 500. So in this last example, we're going to look at the palindromes algorithm. So this is a bit confusing because it's a tricky concept. A palindrome is simply a word or a string that is the same forwards as it is backwards. And a common example of this, or quite a popular one, is race car. So race car is the same if you spell it forwards, and the same if you spell it backwards. So what we're looking at here is tracking 4 values in the trace table. So str in is palindrome, I up, and I down. Okay, so it gives us a piece of test data. So the first value for str in is going to be this one. So ABC, ABA. And so we can see here the first row in the trace table is always the initial values before the loop, or the first value each variable gets. So is palindrome is going to be true, because that's what it's set to. I up is going to be 1, and at this point we're using the len function, so I down is equivalent to the len of string in. So because string in has ABC, ABA, what we do here is we count the number of characters. So this is a 6-letter string, so therefore I down is going to be 6. So at this point the loop is going to run until I up, until this statement evaluates to false. So I up is less than I down. So because 1 is less than 6, the loop is going to run. So the first one is we're using this char at function, which returns a specific character in a string based on an index. The string is str in, so ABC, ABA, and I up is the index. So what this is saying is find the character at index 1 in ABC, ABA. So that's going to be A, obviously. And then the next one is the same thing again, but instead of I up, we're using I down. So this is character 6, so therefore that is going to be the last character. So it's saying, if A is not equal to A, then is palindrome becomes false. So that statement is not true, because they are the same, so therefore is palindrome is just going to stay as true. What happens after this is I up is incremented by 1, and I down is decremented by 1. So I up goes up to 2, and I down goes down to 5. So again, the string is the same, but we're now going to perform the same test again, but this time we're going to be looking at the second character in the string and the fifth character in the string. So this time it's going to be B and B. Okay, so again it's going to evaluate to false. So if B not equal to B evaluates as false, so therefore is palindrome doesn't get reassigned, it's going to be still true. So now we're moving up. I up goes up by 1. I down goes down by 1. At this point we've got 3, 4, so it's the same thing again, but we're looking at the third character in the string, which is C, and the fourth character in the string, which is A. Okay, so at this point what happens is this statement: if char at str in I up is not equal to char at str in I down, so what that simplifies to is if ABC ABA at position 3 is not equal to the character in ABC ABA at position 4. So is C not equal to A? And this time it evaluates to true, so what happens is palindrome gets reassigned, so it becomes false. And the rest of the loop happens, so I up goes up by 1, so it goes up to 4. And I down goes down by 1, so it goes down to 3. This will then go back up to the top, so while I up is less than I down, so now because I up is 4 and I down is 3, this evaluates to false, so therefore the loop stops. Okay, the last one I'm going to look at is one from the new sample specification questions, and this one's a little bit simpler, but they're trying to make it harder because it's a bit more ambiguous. So this time the variables have rubbish names. You would lose marks for doing this in your controlled assessment, but the exam board thinks it's okay in the paper. So we have A, B, and C. It's asking us to call the function total out with the arguments 3 and 4. So we did this again in the car model exercise. So A becomes 3 and B becomes 4. So A is 3, B is 4. We can see that C is assigned to the total of both A and B. So if we add 3 and 4 together, that gives us 7. And again, we've got a while loop, so it's going to say whatever A is less than C. So is A less than C? Yep, 3 is less than 7. Then do these 2 indented lines. So A is A plus 1, so A goes up by 1, and B goes down by A. So 4 take away 4 is 0. Okay, nothing happens to C, it still stays at 7. Moving on to the next iteration of the loop, so 4 is still less than 7, so yes, A is still less than C. So A goes up by 1 to 5. B goes down by A, so this time we've got 0, which is B, and 5, which is A, so 0 take away 5 is going to be minus 5. Does the loop still run? Well, yeah, because A is still less than C, so therefore A goes up by 1 to 6, and this time we've got minus 5 take away 6, which gives us minus 11. And does the loop still run? Well, yeah, one more time. So A is less than C, so 6 is less than 7. So one more time, A goes up to 7, and this time we've got B, which is minus 11, take away 7, so minus 18. And then the loop will stop, because this statement is no longer true. So while A is less than C, so 7 is not less than C, 7 is not less than 7, rather they're equal, so therefore the loop will stop. So what we've been looking at in this tutorial is how to do the trace table questions in the COMP2 examination.